Okay, so today's standard, okay, 1, 10, 18, has to do with radical functions. Radical functions. Or f of x equals some n root of x. So we're really only going to talk about two graphs, square root and cube roots. We can talk about fifth roots and fourth roots and all that stuff, but we are only going to talk about square roots and cube roots. Okay, so example 1. Okay, so this is a parabola. Okay, this is a parabola, and I want to go back to parabolas before we talk to the other because we know how to do this, right? If we plug in 0, 0, 0, right? 1 squared is 1. We know this one. 2 squared is 1, 2, 3, 4, right? Remember these? 3 squared, 1, 2, 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Remember this, right? Right? And then, yeah, thank you, Alexis. And then we know that same thing on the other side. You know, negative 1 squared is positive 1. Negative 2 squared is 1, 2, 3, positive 4, right? We've done this. This is old stuff. 3, negative 3 is 9, positive 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And we get this parabola, right? This is a parabola. We've graphed these before, right? Done this a ton of times. The vertex is the very most bottom or very most top point, and it, in this case, is at 0, 0, right? This should be easy. Domain, it goes forever both directions, so the domain of this is x equals all real numbers. Thank you, Megan. X equals all real numbers, and the range is y is greater than or equal to 0, right? Starts at a height of 0 and goes up. Okay, so this is not new. We've talked about this lots of times. These are basic parabolas, okay? Now, if we wanted to move it or shift it, right, we've done this before too. On example 2, very similar problem, example 2. We know that our vertex is at positive 3, 2, because it's the opposite, right? It's the opposite, right, of the inside one. So I know that my vertex then is at 3, 2. So I go to 3, 2. There's my vertex. And we'll do the same thing. We're going to take the parent function, which is our parabola, 1, 1, 2, 4, 3, 9, right? We'll put the parent function back here, okay? 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, easy, right? We'll go and do 1, 1, 2. We know it's symmetrical, right? And we know it's symmetrical, and the line of symmetry goes right through there. And that's how we get the other half of the parabola. Okay, I'm not doing anything new. We've done this quite a few times. Go ahead and graph that in, right? So it should look something like this. Okay. All right. We're getting to the square root graphs. We're just practicing the parabolas because the square root graphs are just the inverses, right? So the last one on this page, old parabola, this is stuff we know. The vertex is at negative 1, 4, because remember it's the opposite of that, right? Right? You guys remember that? It's the opposite of that. So we go to our negative 1, 1, 2, 3, 4, right? And of course it's upside down. I know it's upside down. It's going to be a frowny face, not a smiley face because of the negative, right? So it's going to open up, what they say, open down instead of open up. So we'll still do our 1, 1 and our 2, 1, 2, 3, 4. Same thing here, here. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course there's the other because it is symmetrical with its line of symmetry, which goes right through the middle. Okay, now this should hopefully be, Mr. Davies, old stuff, easy, right? 2 thumbs up, correct? Correct? 2 thumbs up. I mean, really, we know if we don't know how to do this, I'm sorry. You've been sleeping all year, all semester, right? Now, if we turn the page, what we are going to see is that square root graphs are just going to be the inverse of these, where our x values become our y values. You with me? My x values become my y values, and my y values will become my x values, and we will get its reciprocal. So let's graph y equals the square root of x. So we're going to go square root of 0 is 0, right? Square root of 0 is 0. Go over 1. Go over 1. Oops, hold on, there you go. Go over 1. The square root of 1 is 1. So go up 1, okay? Watching carefully. The square root of 2 is a 1.41. Square root of 3 is a 1.73. Now, I know these because I have a sick mind, okay? But let's take something. Let's graph the next easy. Let's go to 4, right? Because what's the square root of 4? 2. I'm not going to go 5 because square root of 5 is 2.24, but you could really care less. I'm not going to graph 6, 7, 8, but how about we go all the way to 9, because what's the square root of 9? 3, right? 1, 2, 3. So the numbers I like to put in, I like to let x equal 0, 1, 4, and 9 when I do my t-table. And no negatives, right? No negatives, because you can't take square roots of negative numbers, okay? So then my graph looks like this. And again, we talked the fact that there are no negatives because you can't put negatives in, and it never equals a negative, so you won't have any values down here, right? So that is our square root graph. Domain, we know the domain is x is greater than or equal to 0, and our range is y is greater than or equal to 0, okay? This is not that difficult. You guys agree? Okay. So I can't call this a vertex because it's not really a vertex. Let's call it an end point, okay? So my end point is at 0, 0. It wouldn't be a vertex. Let's call it an end point, where we start. Or a starting point. You want to call it a starting point? That's okay with me too, okay? All right. So example 5, we're going to apply what we were doing before. So our end point, or starting point, is going to be at positive 3, 2. Because it's just going to be the opposite of that, right? So we're going to go to 1, 2, 3, 1, 2, right? And we're going to take this graph above it and just put it here, right? It's just a translation of our original parent function down here. So the numbers we always want to use, 0, 1, 4, 9. I'll say it. We want to use 0, 1, 4, 9 because we know those square roots, right? 0's there. If I go over 1, square root of 1 is 1, so go up 1. Go back to my endpoint. Go 1, 2, 3, 4, because we know the square root of 4 is 2. 1, 2. Go back to my endpoint. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, because I know the square root of 9 is 3. And of course, the points in between are there also. Okay, they are. But we don't need the decimals, right? We don't need 2, and we don't need 5. They are on my graph. Okay, domain and range. So the domain's different, isn't it? The domain is x values. Well, it started at 3, didn't it? Started at 3. The domain started at 3 and then went over. So the domain is x is greater than or equal to 3. The range, it started a little higher, didn't it? I mean, the height of this thing, it actually started at a height of 2, right? And then went up. So the range is going to be y is greater than or equal to 2, right? It's actually pretty easy. Thumbs up? I think today is a much easier day than what you've had the last few days, right? All right, slide this over, okay? All right, first let's do the parent function right here, okay? Let's graph the parent function. And we kind of did, if I took 0, okay, 0, cube root of 0. Cube root of 0 is 0, right? 1. Cube root of 1 is 1. Okay, now I got to be careful because cube root of 2 is, some ugly decimal. Cube root of 3 is some bad decimal. Cube root of 4, cube root of 5, those are bad numbers. But the very next number I can get is 8 because there is a cube root of 8. And the cube root of 8 is 2, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. And the cube root of 8 is 1, 2. Okay. Now we can do negatives. So let's look at negatives. Okay, you can do negatives. So we can go, all right, negative 1. So we go back 1. Cube root of negative 1 is negative 1 because negative 1 times negative 1 times negative 1 is negative 1. I'm going to go all the way to negative 8, okay? I want to go all the way to negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Cube root of negative 8 is negative 2, okay? And I could put all the numbers in between, but then I get ugly decimals, right? So the numbers I need to do this one, basically, if I plugged in 0, 1, 8, and negative 1 and negative 8, if I let these be my x values, then it's pretty easy to go ahead and graph it. Now my graph is going to look like this. There it is. So we want to move or translate this graph. Okay, this is my parent function. And to translate it, we're going to do the same thing. We're going to take this graph and move it. Now, this is not a vertex. Okay, everybody looking? Everybody looking? This is not, right here where I'm at. This is not a vertex. It's not an endpoint. It's called an inflection point. So we're going to move our inflection point. It's called an inflection point. And I'm going to highlight it and circle it. Okay, this is the point we want to move. Right there. It's called an inflection point. So that's the point we move when we translate our parent function, okay? So let's go back up and take a look at graphing this one, okay? So if I want to graph y equals cube root of x plus 1 minus 3, my endpoint then is going to be at negative 1, negative 3, right? Negative 1, right? Negative 1, opposite of the inside 1, negative 3, okay? So I'm going to find negative 1, negative 3 right there, okay? Didn't copy very well, did it? Kind of a mess. And I'm just going to take my parent function now, parent function of this function, and put it right there. So all I'm going to do is take this parent function and put it there, because that's where my inflection point goes. So we'll do my 1, 1, right? Cube root of 1 is 1. I'll go back to my inflection point, and the next number I need is 8, because I know cube root of 8. So I'll go from my inflection point 1, 2, 3, 4, 5, 6, 7, 8, and I'll go 2, okay? So I went from my inflection point, I went 8 up 2. I went 8 up 2, and then for my inflection point, let's do the negatives. So if I go back 1, I'd go down 1 to negative 1. And then I'd go 1, 2, 3, 4, 5, 6, 7, 8, estimate 8, and down to negative 2. Okay, so here's my graph. So we just translated our parent function to negative 1, negative 3, okay? Domain and range, same. It's all real numbers, okay? Domain and range. Domain and range is going to be x equals all real numbers and y equals all real numbers. It goes forever. It goes forever in both directions. Does that make sense? It goes forever in both directions, and it's always going up. Even though it's slowly going up, it's always going up, and it's always going down, just very gradually. But it will always go, it will eventually go all the way down to negative infinity and all the way up to positive infinity, okay? All right, last one, Megan. I'll try not to put you to sleep, okay? I know you are. I know you're not bored. I know you generally look tired, okay? Okay, don't take that wrong. I know the one thing I've learned, don't ever tell a woman she looks tired. I mean, I got a lot of lessons in life that, it's a long life. I've learned a lot of things in life. Anyway, moving on. Let's do this one. So first of all, before I do anything, my inflection point. Is at negative 3, 2, all right? My inflection point's at negative 3, 2. Okay, you guys got that? It is a cube root graph, so it's going to be this shape here, right? It's a cube root graph, so it's this shape. But I have a negative on the inside, not on the outside, but if the negative's on the inside, you're going to flip it horizontally instead of vertically. So we're going to flip it now. Instead of having it go upside down, it's going to rotate along this axis. Okay, it's going to rotate around here. So we're just going to take this graph and we're going to rotate it on that axis. So it's going to look, and it will look upside down by the time I'm done, but here it is, 1, 1, and then we've got 1, 2, 3, 4, 5, 6, 7, 8. Up here 8, and then it will look something like that. very good graph, but there it is. Okay. So, homework, and we do have time. We got 15 minutes. Okay. Got page 624, 2 to 10 all, 24 to 32 all, and I could change these to evens. I'm going to change these to evens. How's that? Even and even. How's that? Does that sound nicer? Evens. Who just left? Oh, well.